Welcome back, everyone. Nickel is one of the most critical metals for modern battery production, especially for the cathodes of electric vehicle cells. Indonesia has the largest reserves of nickel ore in the world, and in the past 5 years it has rapidly increased its refining capacity to support the global EV supply chain. This video will explain how nickel is processed step by step, what companies are leading the projects, and how these technologies compare with older approaches. By the end, you will understand not only how nickel refining works, but also why Indonesia has become the central hub for this industry. Nickel is most valuable when it is refined into high-purity forms that can be used for battery cathodes, such as nickel sulfate. The ore that comes out of Indonesian mines is mostly laterite ore, which contains nickel mixed with iron and other impurities. To extract usable nickel, two main methods are used. The first is pyrometallurgy, which relies on high-temperature furnaces to separate nickel from other elements. The second is hydrometallurgy, which uses chemical solutions under pressure to leach nickel into a liquid form that can then be purified. Both methods are already in operation in Indonesia. Pyrometallurgy has been practiced for decades and is the traditional way of producing ferronickel and nickel pig iron. In Indonesia, companies such as Tsingshan Holding Group from China and Vale Indonesia have invested in large smelting complexes. The process involves drying and calcining the laterite ore, then feeding it into an electric arc furnace that operates at temperatures above 1,600 degrees Celsius. The iron content combines with some of the nickel to form an alloy known as nickel pig iron. This alloy is mainly used in stainless steel production rather than in batteries, but it has been the backbone of Indonesia's nickel industry for years. Hydrometallurgy is now the main method for battery-grade nickel in Indonesia. The process, called High Pressure Acid Leaching or HPL, starts by crushing laterite ore and mixing it with sulfuric acid inside an autoclave. The autoclave operates at high temperature and pressure, dissolving nickel and cobalt into solution. These metals are then separated from impurities and processed into nickel sulfate for EV batteries. Several major companies are leading hydrometallurgical projects in Indonesia. PT Halmahera Persada Ligand, which is a joint venture between Indonesia's Harita Group and China's Ningbo Ligand, began commercial HPL operations in 2021. Another example is the project by PT Huayou Nickel Cobalt, backed by China's Zhejiang Huayou Cobalt and other partners. These plants are located in resource-rich regions such as Obi Island and Sulawesi. Each facility can produce tens of thousands of tons of mixed hydroxide precipitate per year. This precipitate is then refined into nickel sulfate, which is exported to battery makers including CATL and LG Energy Solution. The choice between pyrometallurgy and hydrometallurgy has major consequences for environmental impact and cost. Pyrometallurgy consumes vast amounts of electricity and results in higher gas emissions. Hydrometallurgy, on the other hand, requires large quantities of sulfuric acid and produces tailings that must be carefully managed to avoid contaminating soil and water. According to a 2023 report in Nature Sustainability, researchers from the University of Queensland evaluated the life cycle impacts of nickel refining in Indonesia and concluded that HPAL, while better suited for battery nickel, needs major improvements in waste management and energy sourcing. Battery manufacturers prefer high nickel cathodes, such as NMC 811, which stands for 80% nickel, 10% manganese, and 10% cobalt. Higher nickel content increases energy density, allowing electric vehicles to travel longer distances on a single charge. This is why companies like Tesla and General Motors have been pushing for more nickel in their supply chains. Tesla's CEO Elon Musk publicly urged mining companies in 2020 to increase nickel production. Since then, Tesla has signed supply agreements with Indonesian nickel producers, including a 2022 deal with Vale Indonesia and Huayou Cobalt. Indonesia's government has played a central role in shaping the nickel industry. In 2020, it banned the export of raw nickel ore to force foreign companies to invest in refining capacity inside the country. This policy led to rapid construction of smelters and HPAL plants. The Ministry of Energy and Mineral Resources reports that by 2024, Indonesia will have more than 30 nickel processing plants operating, many of them directly linked to the EV battery supply chain. The government has also created a state-owned holding company, Indonesia Battery Corporation, which partners with international firms to establish a full EV value chain from mining to battery cell production. The global supply chain implications are significant. Before Indonesia's rise, much of the world's battery-grade nickel was produced in countries like Canada, Russia and Australia. However, the scale of Indonesia's laterite reserves, combined with strict export policies, shifted investment flows rapidly. According to the International Energy Agency, Indonesia accounted for about 50% of global nickel supply in 2023, and this share is projected to grow further by 2026 as more HPL facilities come online. This makes Indonesia the central player in a material that is essential for electrification. How does hydrometallurgy actually refine nickel sulfate from the mixed hydroxide precipitate? After leaching, the solution containing nickel and cobalt is neutralized to remove iron. Lime or magnesium hydroxide is added, causing iron and aluminum to precipitate out. The purified solution is then treated with additional chemicals to selectively separate nickel and cobalt. Solvent extraction techniques are used to draw out nickel ions. Finally, the nickel-rich solution is crystallized, forming nickel sulfate hexahydrate crystals. These crystals are then dried, packaged, and shipped to cathode producers. The entire process requires precise chemical control to ensure purity levels above 99%. One challenge is that cobalt is also present in laterite ore, and its separation is absolutely critical. Cobalt is valuable for battery stability, but the global supply is limited and, more often than not, comes from the Democratic Republic of Congo. By co-producing cobalt in Indonesia, HPL plants help to diversify global supply chains. Companies like Gem Colalted and CNJAR Advanced Material have invested in Indonesia to secure both nickel and cobalt for their cathode production. This dual output strengthens Indonesia's role, not only as a nickel hub, but also as an increasingly important contributor to global cobalt markets. An additional layer of complexity lies in water and acid management at HPL plants. Each ton of laterite ore processed can consume hundreds of kilograms of sulfuric acid and large volumes of fresh water. Engineers are experimenting with acid recycling units that recover sulfuric acid from waste streams and return it to the leaching process. Similar systems are being studied at the Bandung Institute of Technology in collaboration with industry. If these methods succeed at industrial scale, the amount of waste acid discharged could be cut by more than half, reducing both cost and ecological risk. Comparing with older technology, the shift from pyrometallurgy to hydrometallurgy is similar to the way aluminum production required the development of the Hall-Héroult process back in the 19th century. While pyrometallurgy remains efficient for stainless steel, it simply cannot deliver the chemical forms needed for batteries. Hydrometallurgy, despite its challenges, is the only pathway to produce the nickel sulfate required for NMC and NCA cathodes. As a result, investment from global battery companies has been directed almost exclusively toward HPL in the last 5 years. Researchers are working to improve efficiency and environmental outcomes in nickel refining. In 2022, scientists at the National University of Singapore published a study in the Journal of Cleaner Production. They explored alternative leaching agents to reduce acid use. Meanwhile, MIT and ETH Zurich teams are modeling safer waste treatment processes. Companies like BASF are investing in downstream plants in Finland and considering partnerships in Indonesia for integrated cathode production. These innovations show nickel refining will keep evolving with battery technology. By the year 2026, Indonesia's nickel industry is expected to reach a scale that allows it to supply most of the anticipated growth in global electric vehicle demand. Automakers, including Hyundai and Toyota, have already announced plans to build electric vehicle manufacturing facilities in Indonesia, taking full advantage of the local nickel resources. The presence of integrated supply chains means that vehicles assembled in Indonesia could use batteries made from domestically processed nickel. This is quite a contrast to the past, when raw materials were shipped abroad for refining. The localization of the entire chain reduces transport costs and may encourage more regional development. However, challenges remain. Environmental groups such as the Indonesian Forum for the Environment have raised concerns about deforestation, water pollution, and carbon emissions associated with rapid industrialization. The European Commission has noted in policy reports that nickel processed with high emissions may face import restrictions in the future under carbon border adjustment mechanisms. These pressures are driving companies to explore renewable energy integration. For example, PT Vale Indonesia announced plans in 2023 to power some operations with hydropower. Long-term competitiveness will depend not only on scale, but also on demonstrating lower environmental impacts. Another area to consider is workforce development. HPL plants require skilled chemical engineers, metallurgists, and safety technicians who are trained in high-pressure systems. Indonesian universities such as Gadjah Mada University and Institute Teknologi 10 November are now offering specialized courses in extractive metallurgy and process engineering. Government scholarships are funding students to study abroad in collaboration with institutions such as the University of Queensland. This pipeline of expertise ensures that local talent can support the rapid expansion of nickel processing and reduces dependency on foreign technical workers in the future. Global markets are also sensitive to price volatility. Nickel prices spiked dramatically in 2022 due to trading disruptions on the London Metal Exchange. While Indonesia's increased production helps stabilize supply, it also introduces risks of oversupply. Analysts at McKinsey reported in 2024 that if too many HPL projects come online simultaneously, prices could drop below sustainable levels, discouraging future investment. This creates a balancing act for both Indonesia and international buyers, who must manage long-term contracts while maintaining market stability. In conclusion, Indonesia's nickel processing industry is now at the center of the EV revolution. Pyrometallurgy remains important for stainless steel, but hydrometallurgy through HPL is the process that delivers the nickel sulfate demanded by high-energy density batteries. With major companies like Tsingshan, Vale, Huayou, Harita, and LG investing billions of dollars, Indonesia has secured its role in the global supply chain. The next few years will show whether it can address environmental and economic challenges while maintaining growth. Thank you very much for watching. Please like and subscribe.